Looks like we are live. Let's go ahead and get this thumbnail changed and post it to the socials. You know what else we're gonna need? We're gonna need this link. Gonna need to add it to this comment here. If I could. I swear to God, I could. There we go. Right. So now, what I should be able to do. Oops. Accidentally opened the live stream. What I meant to do is copy the link. And then paste it. Okie dokie. Well, that's my first post to Instagram in forever. When was the last time I posted? November. Damn, guys. I'm really lagging with that. Let's get some music going, huh? Hopefully that's not too loud. Then let's post this in the Discord. Everyone else is at work though, so ain't nobody gonna see this. Except for maybe like one or two. Alright, so you might be wondering why the title says learning how to code a child. Well, that's because today we're gonna be working with numbers. And guess what we can do with those numbers? We can add, subtract, multiply, and divide. Wow, isn't that crazy? We can make basic calculations in Python. So, oh, my ear is itchy. We're gonna get started. This is what we worked on last time. We were removing suffixes or the file extensions from the end of this stuff. Alright, so let's go over this. Numbers are used quite often in programming to keep score in games, represent data and visualizations, store information in web applications, and so on. Python treats numbers in several different ways depending on how they're being used. Let's first look at how Python manages integers because they're the simplest to work with. Integers, you can add, subtract, multiply, and divide integers in Python. So 2 plus 3, you get 5, 3 minus 2, you get 1, so on and so forth. In a terminal session, Python simply returns the result of the operation. Python uses two multiplication symbols to represent exponents. So 10 to the exponent of 6 is this number. Python supports the order of operations too, so you can use multiple operations in one expression. You can also use parentheses to modify the order of operations so Python can evaluate your expression in the order you specify. For example, 2 plus 3 times 4 is 14, so 12 plus 2. Or you can make it do 2 plus 3, then multiply it by 5, which is 5 times 4, 20. The spacing in these, so while I say that you can make a child, what you're basically doing is telling the code how to run calculations. So you're still gonna need to know at least like your order of operations, what the actual calculation is, so you can fact check it. just in case. You know, I assume the computer is better at doing math than you guys. It's better than me. So, good luck fact checking that. Have a calculator handy, if anything. Because if you're not getting the number you're supposed to, you messed up the formula somewhere. That's all I can really say about that. The spacing in these examples have no effect on how Python evaluates the expression. It simply helps you more quickly spot the operations that have priority when you're reading through the code. Floats. Python calls any number with a decimal point a float. This term is used in most programming languages, and it refers to the fact that a decimal point can appear at any position in a number. I don't know how that references the fact that it can appear anywhere in a number. Doesn't change that it's called a decimal point. Every programming language must be carefully designed to properly manage decimal numbers so numbers behave appropriately, no matter where the decimal point appears. For the most part, you can use floats without worrying about how they behave. Simply enter the numbers you want to use, and Python will most likely do what you expect. Peep the most likely. Does not mean it always will. You need to be able to do basic math on your own. So, 0.1 plus 0.1 equals 0.2. 0.2 plus 0.2 is 0.4. 2 times 0.1 is 0.2. 2 times 0.2 is 0.4. However, be aware that you can sometimes get an arbitrary number of decimal places in your answer. 0.2 plus 0.1. I don't think they wrote that correctly. Arbitrary number of decimal places. I don't know if that he's just referring to how long the digit is. Decimal places are the decimal points themselves, I'm pretty sure. It's like interchangeable. Decimal places are each in between. So I guess you could say that all of those are decimal points. Everything under a whole number, I guess, is a decimal point. Either way, I'm rambling. I didn't do very good at math. Never was really good at math. I'm still not good at math. So don't come for me if I was wrong, okay? Okay. This happens in all languages and is of little concern. Python tries to find a way to represent the result as precisely as possible, which sometimes difficulty... Ooh, I feel like I just had a mini stroke. Which is sometimes difficult given how computers have to represent numbers internally. Just ignore the extra decimal places for now. You'll learn ways to deal with the extra places when you need to in the projects in part 2, if we ever make it that far. Integers and floats. I hope you all know what an integer is. That is just any number. That's 2 is an integer, 4 is an integer, 3 is an integer. When you divide any two numbers, even if they are integers that result in a whole number, you will always get a float. So 4 divided by 2 is 2.0, or just 2. If you mix an integer and a float in any other operation, you'll get a float as well, which makes sense because 1 plus 2.0, I mean, I guess that would be 3.0. It's not technically wrong, but it's just weird to have 1 plus 2 equal 3.0. 2 times 3.0, 6.0, 3.0 to the power of 2 is 9.0. Just really weird. Python defaults to a float in any operation that uses a float, even if the output is a whole number. So for the underscores in numbers, when you're writing long numbers, you can group digits using underscores to make large numbers more readable. I like that. It's extremely hard for my brain when all of these look like this to know what number that is off the top of my head, but here I can easily visualize it. So 1,000, 100,000, million, and then 14. So 14 million. Easy work. Or is this? Wait. Yeah. 14 billion. Okay. Yeah. When you print a number that was defined using underscores, Python prints only the digits. Is that billion? Am I retarded? Right? Because if you replace that, that's 100. What is this? Alright, it's saying my bitrate is hella low, which I know is false, because I'm pretty sure I have it set. Yeah, it's telling me my bitrate right now. It's just dropping a lot. So I have it set to 6,000, but my internet's not the best. Oh yeah, it's dropping quite frequently. Well, there's nothing really I can do about that. So, sorry if it's really stuttery. Anyway, when you print a number that was defined using underscores, Python prints only the digits. So even if you input this as your number in your code, it'll spit this out. So Python ignores the underscores when storing these kinds of values. Even if you don't group the digits in threes, the value will still be unaffected. To Python, 1000 is the same as 1_000, which is the same as 10_00. This feature works for both integers and floats. So for multiple assignments, you can assign values to more than one variable using just a single line of code. This can help shorten your programs and make them easier to read. You'll use this technique most often when initializing a set of numbers. For example, here's how you can initialize the variables x, y, and z to 0. X, y, z equals 0, 0, 0. You need to separate the variable names with commas and do the same with the values. And Python will assign each value to its respective variable. So x, x, y, y, z, z. As long as the numbers of values matches the numbers of variables, Python will match them up correctly. As for constants, a constant is a variable whose value stays the same throughout the life of a program. Python doesn't have built-in constant types, but Python programmers use all capital letters to indicate a variable. What? Let me read this again. But Python programmers use all capital letters to indicate a variable should be treated as a constant and I'm pretty sure there's a missing word in here. Probably that. Use all capital letters to indicate a variable that should be treated as a constant and never be changed. So this is the all caps. This is trying to say that it is a constant and should never be changed. So there's no way for Python to know that it's a constant, only really a way for us to tell ourselves that this is a constant. So, like it says here, when you want to treat a variable as a constant in your code, write the name of the variable in all capital letters. It's not, Python itself is not going to know, just you and whoever reads it, if they understand this. I guess it's a unwritten rule, who knows. Anyway, we are moving on to some actual practice. Woo! I know, right? So for 2-9, number 8. Oh, that's the name of the lesson. I was very confused, like 298. Write addition, subtraction, multiplication, and division operations that result in the number 8. Be sure to enclose your operations in print calls to see the result. You should create 4 lines that look like this. Print 5 plus 3. Your output should be 4 lines with the number 8 appearing once on each line. Easy peasy. Let's create a new file. We shall save the name. You know, the video, PCC, chapter 2, example 9. We're going to save it as is. And so our lines of code are just going to look basically like that. And we're going to make it as simple as possible. We're not going to bother like pushing around different numbers and whatnot to like all have different equations that come out to 8. Nope. We are going simple. We're going as brain dead as possible. We're doing 1 plus 7 9 minus 1. We're using 1 for everything. We're not playing this game. Simplify everything. That's my only advice. Print 7 plus 1. Oh, I capitalized that for some reason. That needs to be lowercase. Print 9 minus 1. Print 8 times 1. Divide. Print. How do I think it's just backslash, right? Yes, backslash. Eight divided by 1. What else? I think that's it. Alright. So, let's save. Run without debugging. Boom. 8.0. And you're going to get a float because anytime you divide numbers, you get a float, as we just talked about. Alright. Let's move on to the next example. Favorite number. Use a variable to represent your favorite number. Then, using that variable, create a message that reveals your favorite number. Print that message. Easy. No different than the quote example that we did. Alright. PCC, chapter 2, underscore 10. Save. Alright. We're going to name this variable favorite underscore number. Oop. And we're gonna change that to, and you need to add your quotations. I'm pretty sure. Actually, why don't we just test it? Why don't we see together if you need quotations or not? We are going to say 46. Ooh. You know what? I have 2 favorite numbers, and they're really weird. Like, most people are like 4, 7, 9. Then there's me, 46, 92. Those are my favorite numbers. I don't know why. Well, let me explain a little bit. 92 was just my sports number. For whatever reason, I didn't like any double-digit numbers. Like, I never really liked the single-digit numbers either. And the 90s were just always available. Nobody ever took the 90s. And because nobody ever took the 90s, I just took 92. I liked the way that 92 sounded. I liked the way it looked. That's how I got 92. So, that's how I got 92. 46. I don't remember how I started liking this number. I think that's just the number that I got given a few times. And I thought it was just really interesting that, like, you know, complete luck of the draw, I just keep getting 46. Anyway, this is not important. Let's just do 46 in quotations first. And then we are going to say, create a message that reveals your favorite number and then print that message. So we're going to do another variable called message. Then we are going to, equal that to my favorite number is, and then we use braces, and then we say favorite underscore number. Alright. Now we can do a print function and just tell it to print message. Alright. Now let's save that. Is that an N or an M? There we go. And now we will run it. Boom. Oh, damn. No, I messed that up. Okay, let's just take that out. Right? And then we'll save that and run it. It's really weird what knowledge I have of this still left in my brain and what I don't, because I genuinely don't really remember how to do this. So I believe it is F, / right? And then now if I put braces on these, it should work. I think it just needed formatting is all it really needed. No. Does this go out here? No. How do I do this? Maybe this needed to be brackets. What if I save this? And then I run it? No. Still incorrect. All right, this is a good example of when you get stuck. Just go back a little bit. There we go. F. So, So just put like a regular F right here and then save it. Now what if I run it? Nope. Does this need to be in brackets now or braces? Okay, that looks like it changed something. Let's try it now. Haha, there we go. We did it. Okay, so in short, how to do example 10, favorite number using a variable and a message. So I could have completely avoided all of this mess. So I know I just said to simplify things and I made it more complicated than I needed to. I'm going to show you the easier way to do it. Also, really quickly, let's just delete those really quick and save it and see what happens. It works the same. Okay, so you didn't need quotation marks. That was my bad. Second thing, I can delete this whole line of code right here. And I can do this instead. Print F and then my favorite number is, and then braces, favorite underscore number, and this will work exactly the same. So if I save it and then run it without debugging, my favorite number is 46. Literally did not change the output from the first go around. So you didn't need to do that third line of code that I had, where I had it as message. That is more so like, how do I explain this in a way that I'm not gonna trip over my words? That's for like if you needed to use it for multiple people. So like, this is my favorite number, right? But let's say that you're running a website and the purpose of the website is to tell you everyone's favorite number. So instead of saying my favorite number is blah 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 blah, you can replace this with any variable. So like, let's say J underscore favorite underscore number. And then, oh, that's a bad example, I think. let's say name, and you can have as many of these name variables as possible, and then we're just gonna say J, and then we're gonna put under that J underscore fave underscore num, right? And then we're gonna say his favorite number is 6. So what you could then do, so like this is my favorite number, this is the second person, oops, name equal to J. Okay. And then down here you could do that message variable that I was talking to, where you equal it out to say F underscore, and then you can tell it to pull. And then so you remember over here where it's saying that you could like put multiple different things, so you could have like name 1, name 2, name 3, name 4, and then you can have this just assigned to that. So for now you can put name and then apostrophe s, favorite number is, and then do more braces, and then J underscore fave underscore num. And then so now when you print message, you should get J's favorite number is 6. So let's save it, run it. And now that is a super oversimplification of that. There are a lot more steps than just this to have multiple inputs, but the point that I'm trying to make is that this entire line of code's only job is that if you have multiple variables that you want to pull from but say the same thing, that's how you would do that. So there's ways to pull specific integers from in here and have it spit out this kind of output, and this would be universal across my name, Jay's name, anybody's name. Okay, so let's move on from that. Comments are an extremely useful feature in most programming languages. Everything you've written in your program so far is Python code. As your programs become longer and more complicated, you should add notes within your programs that describe your overall approach to the problem you're solving. A comment allows you to write notes in your spoken language within your programs. Comment. I can't stress this enough. Comment on everything. It doesn't affect your code at all, and there's nothing wrong with explaining your thought process to other people, because the way I process how to do 2 plus 4 might be different than how you do 2 plus 4. You might do 4 plus 2, and that's the only way your brain will let you do that calculation with and arrive at the answer. Like, I could show you 2 plus 4, and maybe your brain just swaps the numbers in your head. Like, I know you don't literally do it, but for some people that is the case. I've learned that the hard way, where like my cousin cannot do multiplication without a certain number. Like it changes from number to number which one needs to be in front, but always if it's a bigger number, it needs to be in front. If it's a smaller number, I forget how they explained it to me, but there's like a methodology to the way they move the numbers around the equation. Like if it's a PEMDAS problem, it's not an issue for them. They can still do PEMDAS, but for their brain to start working and like process the problem, the numbers have to look a certain way to them, which I know that's not really how numbers work. But when it's like a plus b equals b plus a, it doesn't really change much, you know? It's like an aesthetic thing. It's like some people can't start work until their whole desk is cleared. And then there's people like me who has a week's worth of stuff that needs to go to their forever homes before you even get started. Now, how do you write comments? You, in Python, the hash mark or octotroph indicates in a comment. Anything following a hash mark in your code is ignored by the Python interpreter. For example, comment.py, hashtag, hash mark, octotroph, say hello to everyone, print hello Python people. All you will get is that. Python ignores the comment and then just prints out whatever line of code. So I can put here at the beginning of my code, favorite number statement. And if I save it and run it again, you will notice that never gets put in the output. Now, what kind of comment should you write? So, like I was saying earlier, anything that you do, it doesn't matter what you're doing, comment about it. If you're doing a simple calculation, sometimes for someone to build off your code, they need to know why you're even doing that calculation in the first place. What is it calculating? What other part of your code is using that calculation? Does that go anywhere that like the user can see, or is it just for you? Stuff like that, that is super useful knowledge to have. It's not necessary. Like, you can read through the code and kind of glean information using context clues, but just being told flat out what something is or does, super useful. And I'm pretty sure we can just go and like look for stuff on the internet and just read their code, and you'll see those hashtags every now and then. So the main reason to write comments is to explain what your code is supposed to do and how you are making it work. When you're in the middle of working on a project, you understand how all of the pieces fit together. But when you return to a project after some time away, you'll likely have forgotten some of the details. You can always study your code for a while and figure out how segments were supposed to work, but writing good comments can save you time by summarizing your overall approach clearly. If you want to become a professional programmer or collaborate with other programmers, you should write meaningful comments. Today, most software is written collaboratively, whether by a group of employees at a company or a group of people working together on an open source project. Skilled programmers expect to see comments in code, so it's best to start adding descriptive comments to your programs now. Writing clear, concise comments in your code is one of the most beneficial ways or beneficial habits you can form as a new programmer. When you're deciding whether to write a comment, ask yourself if you had to consider several approaches before coming up with a reasonable way to make something work. If so, write a comment about your solution. It's much easier to delete extra comments later than go back and write comments for a sparsely commented program. From now on, I'll use comments in examples throughout this book to help explain section of codes. No, he doesn't. At least not right away. Adding comments. Choose 2 of the Python programs you've written and add at least 1 comment to each. If you don't have anything specific to write because your programs are too simple at this point, just add your name and the current date at the top of each program file. Then write 1 sentence describing what the program does. So I actually have adopted this suggestion, just adding your name and current date to the top of each program file. I think that's just super useful for a myriad of reasons. One, you can, well, your name's not as important, but the date, that's a lot more important for me personally, because I get to see my progress of how far my coding has come. That I know about when I was doing something, what I was doing around that time. So like if I don't really understand something, I can date it and come back to it later and be like, okay, so it took me this long to figure out what the solution is. Here's like the problem I was having, like for this project. Let me pull it up, stuff like that, you know? Or even just seeing like when you made something, if it's like due for like a revision. Like if you open a piece of code and you have no idea when you wrote it, you don't know how up to date that code is with your current skill set. Like if you could simplify your code and make it just more efficient and just overall work better, I feel like that's a worth it kind of thing depending on what you're doing. But anyway, we got half of it done. Let's just change this out, and then we are going to comment. So Kabiko, I will not be adding that last name for now. And we are going to write the date. So sorry for breaking the fourth wall if you're watching this in the future. 2-15-2024. All right, so I got the date. And then we can add a second comment. I like to add a comment above every block of code that I have and just briefly say like what the section is about or just like what it does. So we're just gonna call this math practice, or maybe I should name it child code. This is our child that we coded today, guys. Isn't that cool? We coded a child. It does basic math for us. I mean, it only tells us how to arrive at the answer 8, but it does simple math. Very limited amounts of it, but it does it. All right. The Zen of Python. This isn't super useful, so you could be done with the chapter here if you'd really like, but we're just gonna go over it just because, you know, someone might find it interesting. Experienced Python programmers will encourage you to avoid complexity and aim for simplicity whenever possible. Like I've tried to do, my brain just works differently. I like to overcomplicate things for some reason. I hate that I do it, but my brain likes to do it. I don't understand it. That's just how it works. The Python community's philosophy is contained in The Zen of Python by Tim Peters. You can access this brief set of principles for writing good Python code by entering import this into your interpreter. I won't reproduce the entire Zen of Python here, but I'll share a few lines to help you understand why they should be important to you as a new beginner Python programmer. Import this, and then it spits it out. All right, so we're just gonna do that really quick. New file. Python file, save as, and then we're gonna quickly change it. PCC, do underscore, what is this? 11. Save, and then all we are going to say is import this. We're gonna save that. We're also gonna save that, and then we are going to run it without debugging. All right, so this is the Zen of Python. Simple or beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Although practicality beats purity, errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although that way may never be obvious at first, unless you're the Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. So I can break this down a little simpler than this. So beautiful is better than ugly. Nobody wants to look at anything ugly, whether that's a picture, a video, your child. No one wants to look at anything ugly, right? So sometimes we have this innate desire to make things beautiful. However, it's not always possible, but whenever possible, it's better to do so. Explicit is better than implicit. I will pull up a quick definition of that. Explicit, stated clearly and in detail, leaving no room for confusion or doubt. So I'm sure you can guess what implicit means. Implied, though not plainly expressed. Essentially, or very closely connected with, always to be found in, with no qualification or question, absolute. That one, I don't know about that. But this one, applied, though not plainly expressed. that's like saying, well, I never said he was smart. It's like implying that that person is dumb. Simple is better than complex. If you can explain an idea simply, it is generally easier to understand. So like you could say 1 plus 2 equals 3, or you could say if you had an apple and then you grabbed 2 more apples and put them together and then counted them out, you would have 3. You're saying the same thing, but 1 plus 2 equals 3, you're not going to understand that innately. It's implied that you know what an addition sign is. It's implied that you know what an equal sign is. It's implied that you understand which side is which in the equation and what side is doing what. So you could have 3 equals 1 plus 2 and 1 plus 2 equals 3. It's the same thing, but if you don't understand what the equal sign is or what it does, you might not understand that it is the same thing. That's what that's trying to say. Complex is better than complicated. So complicated, that's just overall hard to express. It's hard to tell other people why it is the way it is. Although complex is not always a bad thing. Complex sometimes is just the different steps that you need to take to get somewhere. Flat is better than nested. So if you can write things out and it not have to go through a bunch of different things to get you where you need to be, that's better. So the best way I can explain this is if you know what PEMDAS is. Those things inside the parentheses are what would be considered a nested value. So nested values, they are within a larger set of things. Like if you have a room full of stuff and then you have a box in the middle of the room, that box is nested within everything else. And then when you put stuff in that box, those things become nested within that box within the room. So that's what it means. Flat is better than nested. Sparse, that just means little amounts of things like scattered about. Dense, closely compacted. You can think of density like objects, like you learned in science class. Readability counts, having readable code, having comments, explaining things, i.e. readability. It matters. Other people being able to look at your stuff and quickly being able to understand what you are trying to say, trying to program, that matters a lot. Special cases aren't special enough to break the rules. So that's referring to like uppercase, lowercase, any kind of italics, bolds. What takes precedence is your grammar, your syntax. All of those things are above those cases. Although practicality beats purity, so you don't need to be a purist, is what that's trying to say. You don't need to only do things one way. I know it says there should only be one obvious way to do it, but it does not mean that it is the only way to do something. If something works for you like a little better because of circumstance, do it that way. That's what makes the most sense to do. Errors should never pass silently. If you find anything wrong in your code, mark it, comment on it, and say what the error was when you find it. And then when you find the solution, add the solution. Don't delete the error comment. Keep it there and then put in the solution. So when you revisit this, you could put in the solution, but you might not ever find out what the problem was. So if you ever need to find answers to stuff based off of a problem you're having, not a solution you're having, because rarely ever is that the case, you should keep all your problem comments unless explicitly silenced. There are times when you do want to hide those away just so that you're not confusing people, but rarely ever is that the case. In the face of ambiguity, refuse the temptation to guess. So that's like what I was doing earlier. I tried doing a bunch of different ways to format this code. If you remember, I did 3 lines of code and I had a hard time formatting it just to get it to say what the favorite number was. What I was doing was guessing. I was just throwing stuff at the wall until something stuck, and ended up having to go back and review. So you should refuse the temptation to guess. There's always going to be a documented answer to a problem you're having, especially within coding. There's a lot of good resources out there. You just gotta look. You gotta look long enough. You gotta, you honestly gotta have enough problems to know what to look for, because at first you're not even gonna know how to ask questions. I promise you. You're not gonna know how to Google like the question you need answered and someone give you the correct answer right away. You're just not gonna have that ability. Trust me. So he says here himself, there should be one way and preferably only one obvious way to do it, although that may not be obvious at first unless you're the Dutch. So you are probably going to have to go through a few iterations of your code to find the most obvious one. Like you might even be talking to someone about your code and they'll just say like, why didn't you do this? And like in your head in that moment, you'll realize that your 30 lines of code could have been simplified to like 2, which is crazy to think about. Because that's happened to me. I have a friend who is coding for some big wigs, and I explained the problem I was having and he solved it in like 3 lines of code, whereas I was like on line 62 at that point, just trying to figure out where I went wrong, just adding code after code after code, hoping one of those lines would get me somewhere, and it just never did. And it just become like this big rabbit hole of like 4 problems within the same line of code, and you're just trying to do one thing. So as much as possible, edit your code, comment about your code. Now is better than never. That's just true in life. The best time to do something is yesterday. The next best time is today. Although never is often better than right now. So don't feel like you need to be rushed. Like, don't feel that you need to learn all of Python in the next month so you can land this coding job making 6 figures because XYZ. Take your time. Make sure you understand things. Like, you may never fully understand what a float is, but if you can use it to your advantage, you might not be able to explain it, but it's not really gonna matter. You don't need to know it. And if it takes so much time out of your day, or like it takes effort, too much brain power to try and understand something, maybe you just don't need to understand it. You can find someone who understands it for you. You can have someone help you understand in a different way. Sometimes it's just better to know when to walk away from something. If the implementation is hard to explain, it's a bad idea. That's just running around in circles, getting nowhere, spinning your wheels, the wheels turning but the hamster's dead kind of situation. If the implementation is easy to explain, it may be a good idea. Not everything that is obvious is a good idea. It might seem obvious that you can take someone's stuff if you murder them. That does not make it a good idea. Stuff like that. It's super easy to explain, Murk them, obtain loot. It's a 2-step process. Like, it's not hard to understand. It's like almost universally understood. But that doesn't make it a good idea. Although it is the first step to being a good idea. If anything is easy to explain, you either understand it well enough to explain it that easily, or it just means you'll reach more people. And I know that was kind of like life lessons with Kanai, but yeah, that'll be all for this little stream of coding. Next time we're going to be going through chapter 3, where we're going to be going over lists. Oh boy, did I hate this chapter. Hopefully it doesn't go as poorly as last go around, but I will see you guys in the next stream, or I'm going to be streaming some Power World later on tonight. Maybe you'll join me for that. Either way, hope you guys found anything in this video useful, and I will see you guys in the next stream. Hui ho.